Okay, welcome back. We just finished talking about all the different types of things you can add to your application. You know, we've done java.util, and we've done some, and we're going to add an awful lot more as things go on. Okay, so next thing you talk about on page 382 is a philosophical discussion about, here's a typical business environment, and we're trying to come up with, you know, what to put in a class, and what to put as fields, and what to put in as methods. And so they talk about the steps. The first step is, you know, find all the classes. Basically, make a list of all the things that you're trying to keep track of. And try to break it up into what they call a problem domain. So this is like a car repair shop. So, you know, vehicles, workers, customers, you know, orders, things like that. Identify the nouns that you need. So I need to know, you know, the make, model, year. You know, I need to know all sorts of information about vehicles. I need, for the customer, I need, you know, the name, address, and phone number, and all that kind of stuff. Identify the responsibilities. Who's supposed to do what? You know, when it comes to workers, you know, that's fairly obvious, but, you know, let me give you an example. Let's say that, well, you just can keep going. So then produce a UML diagram before you start writing. And then you pass them out. You say, okay, you're going to do the customer one, and you're going to do the vehicle one, and you're going to do the, you know, the service requests or service quote thing. So I'm responsible for doing service quotes, and I'm looking over the list, and I'm going, hey, you know, one of the things I need to do is to do a state inspection. And with the state inspection, I need the VIN number from the vehicle class, and I need the insurance from the customer class. And so I look at the UML diagram like, oh, okay, there's the VIN number, got it. But I don't see anything about insurance. And so that's how you do this. It's done on paper. I mean, you know, by looking at passing the UML diagrams around, I go talk to the person who's supposed to be writing up the customer class and say, hey, you need to add a field with some getters and sitters so that I can get what verify that they have insurance before I can do my part of the job. See how this works? And so you can work out an awful lot of the problems even before you start writing the app, which is what this whole thing is about. So in this scenario, let's say that there's only three classes. There's a customer class, a car class, and a service request. So each class can be assigned to different programmers, and everyone knows what the fields and methods that are going to be used, even though it hasn't been written yet. We all know what everyone else is doing, and I can write my part of the application without having the VIN number ready and without having the customer with. All I have to do is say, I know what it's going to be called, and so I'll go ahead and put that in my code. It won't run, but I can actually do my part so that when we finally put the parts together, everything is cool. Okay, so let's talk philosophically one more time. At the end of the previous chapter, we talked about the benefits of, putting things in methods. Remember that? And let's just go through the list because it's not that long. It's easier to concentrate because you're thinking about smaller number of things. It's easier to do debugging. It's easier to break up tasks among programmers. And I can reuse the code without having to copy it, okay? Well, you take that and just add a little more to it, and we're talking about doing classes. The last one is the one that changes the most, in that when I'm working with a class, I don't have to have the source code in order to accomplish that goal number 4, of being able to reuse the code like that. Because I don't have the source code to scanner, and I don't have the source code to print writer. I don't need the source code to that. All I need to be able to do is just reuse those components. And so that's how the encapsulation that we talked about with regard to methods is different than the encapsulation we talked about using classes. Okay, before we go much further, let's just do a quick review on how it is you pass data from a calling class until some other class. So for example, if I have a Chapter6 class and I want to talk to a rectangle class, how do I do that? What's the mechanics of it? So let's just go through that. Okay, so this is the only way that you pass data between classes, so pay attention. So to pass data to a class, so from the Chapter6 class to the rectangle class, only way I can pass data to it is via parameters. It could be a parameter of a constructor or a setter or some sort of a method, but it always goes over as a parameter. Now, to get data back, it's always from some sort of a return type, such as the return type from a getter, or the return type like calculate area, which is a method. Okay, is that making sense? So the way it works is you create an instance of the class, and then using that instance, you use the methods in the class to pass data to it. Then you use methods in that class to be able to pull data from it. Got it? Okay. So let's talk about some things that are not in the book that you need to sort of need to know. We're going to talk about the static keyword. Now, we've used static an awful lot, and I've been kind of brushing it off. And to tell you the truth, I'm going to almost brush off again. I'm going to show you just enough to get this point across, and then with a promise that we'll come back and hit it again. All right. So the word static in this particular context means something strange. If I was to go to my rectangle class and create me another constant in here. So let's say, this is a stupid example, but I'm going to go, final, public, int, I don't know, max age, because we've done that one before, right? Something like that. Okay. But inside my application, I want to be able to see that thing, the thing called max age, before I create an instance of the object. Okay? Now that sounds a little weird, because up to now, the only way we could talk to an object is by newing them up to create an instance of the object. Otherwise, they're deaf and dumb. Well, static will allow me to talk to the recipe. Now, there's some problems with talking to the recipe, in that when I talk to the recipe, obviously all the instances are going to be the same, right? Okay. So if I just put the word static in here, static makes that guy viewable from here without having to create an instance first. So I could go here and say rectangle dot and get max age and use that guy in something. Okay? So I don't know, something like, let's just do something simple. Let's just do a system out. All right, the reason why we have to deal with this guy now rather than later is you have a homework assignment coming up, and I don't want to confuse you about where to put things. It shows over here exactly what it's supposed to show, but I didn't want you to get confused. So the word static means, in this context, the word static means I don't have to create an instance of the object to be able to talk to it. Okay, that's what that means. How useful is that? Well, mainly for things like, min age and max age and, min score and max score, those kinds of things that I want to bundle with the rectangle object. I really want to bundle it with it, but I want to be able to get to those things even before we create an instance of the object. Okay, that probably isn't a very good example, particularly max age, but when you start looking at the assignment, it's going to make a little bit more sense. Okay, so let's also look at more about this thing. I mean, I've been showing you this, and but there's an awful lot of symbols here. The little bar going through there means it's static. So that's a field, and that means it's private. The diamonds are the constructors. So I have a rectangle and a rectangle and a rectangle, and then the red circles are all of the methods. Okay, cool. But if you really want to look at a list of those guys, I found this thing on the NetBeans website, where at the very bottom there's an appendix that shows all of those guys. Like, what is a class? What is a package? What is an enum? We haven't even done the enums yet. What are the constructors? And then protected and private, and then what are the fields and protected and private, and a static field, and interface, and methods, and static methods, and local variables, and all those kinds of things. So this is a good way to kind of get all those symbols, because you're gonna have to be able to read those things to be able to figure out what it is you're supposed to do for the assignment. Okay, before we leave this chapter, I want to talk about something that you may have noticed in the book and in lecture. Whenever we create a user-defined class like rectangle, rectangle does not directly talk to the user. There's no system.in, there's no scanner, there's no keyboard thing, there's no system.out, print line, or any of that stuff. This is not a coincidence. It's a very good idea to have separation where the thing inside main is where all the user input takes place, and then that guy just attaches to this class and passes information back and forth. The class itself, this user-defined class, very rarely ever talks directly to the user for any reason. Okay? So again, that's not a coincidence, and that's part of the rules that I'm going to expect you to do in your assignments. Okay, so let me tell you a story. So, a million years ago, I wrote a calculator app, and I wrote it in the C language, and it was pretty cool. I liked it. And then I said, well, I'm going to rewrite it for make a Windows app out of this. In the time, it was DOS and Unix was what I was writing for. So this came time for me to write a Windows version. So I just copied the thing over as best I could and just made it all done. I did it in one gargantuan file, one source code file with everything in it. And it was just quick and easy. And I keep thinking to myself, all that oops stuff I've learned in school, that doesn't really apply to me because I'm just, I'm not working in a team. I'm not working in a commercial enterprise or something, so I don't need all that stuff. And so I was happy. And so one day someone said, hey, could you make a web version of this? And I went, sure, that shouldn't be tough at all. I can do that. So I created me a web application, copied my source code over, and then, man, it lit up like a Christmas tree with all the things wrong with it because, I was talking to, it was a console application before. So I started, commenting out sections. And after about an hour, I still had not got it so it would compile. So I thought, stop. I really need to break this out. So I stopped working on the web version, went back to the Windows version and broke it up into chunks. The user interface chunk that was for the Windows, and then all the rest of the calculator engine separate. And then after I got that working, then I went back to the web project, and then it was easy. I could just copy the file over and everything worked. And afterwards I went, there might be something to this oops stuff after all. Okay, I guess I'll consider doing that again. And then a couple months later, after I published my code, I got a note from someone saying, hey, I'm not using your entire calculator app. I'm just using a component of it in some sort of industrial operation. And when I do this operation, I don't get the correct answer. And so my first instinct was, well, there's nothing wrong with my application. You must be doing something wrong. And so I was drafting an email to send to him saying, well, you need to set this option before you do this. Otherwise, you're doing them out of order. And I'm about to hit the send button when I went, I really need to put secondary input validation in that component. So I went back a second time and put in all the secondary input validation. And so then after that, after doing the encapsulation and then going back and adding the secondary input validation, by the time I was done with that, I became a believer. And I said, man, I ain't never doing that again. Every single program I write from now on is going to be following the principles of OOP. So I became a believer.
Now I'm a believer. Not a trace of doubt in my mind.
It took some tugging, and I didn't immediately see the benefit until I was asked to port an application from one platform to another. And then I went, oh man, this is going to take forever. Okay, so this is the end of the chapter, and I'll see you guys again in the next chapter.